Hello, this is Dr. Kevin Connors, and today's presentation is on biotoxins. The word bio means living, and a prefix, and toxins is obviously a toxin, a substance that's not good for your body. So when we talk about biotoxins, we're talking about living organisms. Now, I separated this presentation into two presentations so that they wouldn't be quite so long and you could choke through them. Now, this is a very common issue that we deal with patients. So when we're talking about living pathogens in a person's body, it's a very common condition because just about everybody, you could say, has some sort of parasitic infection. Doesn't mean that we need to be attacking it. It doesn't mean that it's causing the person a lot of symptoms. Not necessarily. Understand that there's bacteria and virus that live inside your body symbiotically as well. So they're living in a symbiotic relationship, meaning that they are living off of you, but they are actually helping you too. So it's not that we want to rid our body of every single possible pathogen. It just means we want to rid our body of pathogens that are making us sick. So as an example, if you swab the throat of 100 people on the street and that none of them have any throat condition or any sore throat or any cough or cold, a vast majority of them are going to show positive for strep because strep is part of your normal flora. So does it mean that everybody should get on an antibiotic and kill every pathogen in their body? Absolutely not. We don't want to do that because that is the problem that we have right now, really, isn't it? We've destroyed our normal flora, which are hundreds of millions of different organisms that are keeping everything in balance. As soon as we take an antibiotic, we throw that off balance. Now, I'm not against use of antibiotics when we need to use antibiotics, but it's when we need to use antibiotics, and then you have to help heal that flora. So the living organisms that we're talking about, the biotoxins that we're mainly discussing, are bacteria, virus, mold, fungus, and parasites, and we'll get through the top two. This is just an overview, understand. So I'm going to have further presentations on each one of just single bacteria that we're going to talk about, or single virus organisms that are so deadly and causing so many problems as you go here. So initially, we're just an overview of different bacterial infections. Now understand that out of all these things that we're talking about, really bacteria is the only thing that's really going to be that antibiotics are going to be effective against. And should you take, okay, so you look at this little chart here, the top one is strep. So should I take antibiotics if I have strep? I had a mother in the other day saying, oh my gosh, my daughter had strep and she had such a sore throat and she was coughing and mucousy. We brought her in, they did a culture, they gave her antibiotic. Should you do that? That's always the question. Well, nobody can completely answer that question, not a doctor either. I don't want to be the one that answers that question either. I always like to ask a question when a parent asks me that question. I ask them a question back. If a person obviously has a strep so bad that they are, their throat is closing up, they're just very, very sick, then using an antibiotic to knock that strep down is probably the right way to go. But here's the problem when you take an antibiotic. Now, normally, remember the immune response. Normally, a person is exposed to, we'll use strep. So you're exposed to strep. You fire an immediate immune response. That's your Th1 response. So your Th1 response, remember, is all your immune cells, all your killer cells. So think of them as they are the Marine Corps with machine guns that are going out there to try to kill that strep. So when they are firing and when they are attacking the strep, they are doing damage to self-tissue at that time too. So part of the person's sore throat is actually your own immune response killing strep that are there too. So it's not just the strep that is causing the swelling of the throat. It's really an immune response that's causing that, which is good. That's what you want. And then I got a sore throat, so I have this Th1 system firing here for the first 24 to 48 to 72 hours. My Th1 system is firing to kill this. So I go in, take my child in, the early signs of this, and they say, yep, she has strep, so here we're going to give you this antibiotic. And you take the antibiotic, and if it is strep, a bacterial strep, then it will usually kill the strep, and that's a good thing, right? But is it? So if I killed a bacterial infection with an antibiotic before you were able to elicit a Th2 response, so remember, your immediate immune response is a Th1 response. After 24 to 72 hours, if that cannot kill the infection, it suppresses and you fire this Th2 response. And the responsibility of the Th2 response is primarily to make antibodies against that thing which the Th1 response initially fired against. So in their case of our example would be strep. So after about 24 to 72 hours, my Th2 response fires and I start to make antibodies against strep. Is that a good thing or a bad thing? That's a very good thing. So now I'll have circulating antibodies against strep, against this specific strep, which will react to a lot of different streps. There's hundreds of different streps, understand. So it'll react to a lot of different streps. And so I have these circulating antibodies for anywhere from a year to 10 years, which is that a good thing or a bad thing? It's a very good thing. So I've created an immunity per se. It's not going to be perfect, as no immunity is perfect. But if I allowed my body to go through a Th1 suppression, then Th2 reaction, and my Th2 system started making antibodies against that which my immune system initially fired, well, I am actually increasing the health of my immune system, because now I have circulating antibodies against that pathogen. So the next time, 3 months later, I'm exposed to strep again, well, I might not get any symptoms. So why does one person, three people go to a party and all three of them are exposed to the same strep from that sick person with strep? Let's pretend they're all exposed to the exact same number of organisms. And why does only one of them get sick and the other two don't get sick? Well, the other two had, number one, a healthy enough Th1 response to kill it off, or they had already had circulating antibodies. So as soon as that body was exposed to that strep, that circulating antibody tagged it, and when you did get that initial Th1 firing, it found it right away and was able to kill it. So by not allowing your body to go through that Th1, Th2 reaction, you'll never really strengthen your immune system. Now that doesn't mean that you never get an antibiotic. There's certain infections, and we'll talk about Lyme disease. I recommend that you get an antibiotic even at first thought that you have Lyme disease, because your immune system will typically not be able to kill that. So, and if it goes to a chronic or autoimmune Lyme, we got lots of problems. But a strep is one of the nasty ones. But if you have another bacterial infection, to get an antibiotic is maybe not the right thing to do right away. If you ride it out just a little bit longer so you can fire a Th2 reaction, and then if you have to get an antibiotic, you can. Well, how do I know I fired a Th2 reaction? Well, you don't, because a person could fire a Th2 reaction within the first 24 hours, and it could take 3 or 4 days. We just don't know that. However, it is usually safe to ride something out. Now with kids with infections, we're not going to get into the whole what should you do with each individual case, but if their fever gets over 104, then you have to do something. So I'm not saying that we don't want to. This is an integrative clinic, and these are integrative lessons. So we don't want to throw out modern medicine. We want to integrate it and just try to use wisdom in everything that we're doing. So bacteria are the only thing that are effective against antibiotics, or I should say that antibiotics are really effective against. Now there's two main classifications of bacteria. There's gram-positive and gram-negative bacteria. And they're named so because of how they stain with a gram stain when you look at them on a slide. However, the reason why they stain that way is because there's something very different in their cell wall. So the cell membrane of gram-negative bacteria have another thing in it called a lipopolysaccharide coating. So this lipopolysaccharide coating on a gram-negative bacteria makes it often a little bit more of a nasty bacteria. Lyme disease, the Borrelia bacteria, is a gram-negative bacteria. H. pylori is a gram-negative bacteria. And when we kill Lyme disease or H. pylori, when you kill any gram-negative bacteria, even using an antibiotic to kill it, you liberate this lipopolysaccharide. And I do a whole lecture on H. pylori, and I do multiple lectures on Lyme disease, so I'm not going to get into it too deep. But when you kill a gram-negative bacteria, you liberate this lipopolysaccharide, and it becomes an endotoxin in the person's body as well that you have to deal with. And many times you have to chelate that out. But that's for another time. H. pylori you hear a lot about with stomach ulcers because it is the primary cause of a stomach ulcer. Used to think stomach ulcers were caused by too much stress, and stress caused your stomach to make more hydrochloric acid, and it was just this excess amount of hydrochloric acid that causes stomach ulcers. Well, thank goodness through the modern science, has finally agreed with what we were saying many years ago, is that that is ridiculous. It is some sort of infection. Well, we found out what the infection was. Modern science did a few decades back and won a Nobel Prize for doing so, that it was H. pylori. H stands for Helicobacter. Helicobacter pylori is a bacterial infection. It's a gram-negative bacterial infection that is everywhere. It's ubiquitous. You cannot not be exposed to H. pylori. Now, well, why doesn't everybody have stomach ulcers? Well, if you have enough stomach acid, this is the little twist on this, if you have enough stomach acid in your stomach and you swallow some food that has H. pylori in it, your stomach acid kills it, so you don't have any issues. It's only when you have a decreased stomach acid, when you have a hypochlorhydria, that you even are susceptible to H. pylori. Now H. pylori, this is a picture of H. pylori migrating through a gastric cell into the cells right underneath the gastric cells, the epithelial cells, and causes this infection, and it just erodes away and causes this hole in this person's stomach, and they bleed from it, and that's a stomach ulcer. However, most of the time, maybe upwards to 90% of the time, it does not cause a stomach ulcer if the HCl is high enough for it to, the pH is high enough and the HCl is low enough for it to even live in the stomach. Many times it will go right through the wall and enter the bloodstream, and then we have really problems, because H. pylori is one of the top 5 causes of cardiovascular disease. It is a major cause of cancer. It's the #1 cause of stomach cancer worldwide. It is a major cause of many cancers. It's a bad guy. So this talks about endothelial cells in vitro with H. pylori and some other studies with cardiovascular disease, but I'll save that information for when we get into a whole lecture on H. pylori for you guys who want to dig into that. This talks about it being a major cause of cancer. What it does is it affects the receptor sites. So it blocks apoptotic receptor sites on the outside of the cell, and it infiltrates the cell and can change the replication cycle. So it's a nasty little beastie. And this is what a lot of the gram-negative bacteria are, is they have the ability to enter the cell. So most bacteria do not have the ability to enter the cell. So that's what differentiates, a big part of what differentiates how a bacteria acts in the person's body and a virus acts in the person's body. A virus typically will infiltrate the cell and actually will end up killing the cell. Now, a bacteria typically does not infiltrate the cell, but some gram-negative bacteria do. Lyme is another one of those. H. pylori is another one. That's why your immune system can't kill it, and that's why if you don't catch it when it's in the blood vessel, an antibiotic won't kill it. So if you have a chronic H. pylori or a chronic Lyme, you can't take an antibiotic because it's no longer extracellular. It's no longer in the bloodstream. It's hiding in the different cells. So this is the Borrelia, the bacteria that causes Lyme disease. It has that, it looks like a little spirochete, and it goes and hides inside the cells. Okay, so next week we're going to talk about viruses. And don't worry if you didn't get your earful of the Lyme and the H. pylori, because those are so prevalent that we see in our practice. We have multiple presentations on each one of those. And I'm constantly pulling up new research on those, and I put together a whole presentation on that research paper for you eggheads out there that are like me that want to know this information. So, but next week we're going to talk about viruses, and then Lyme, or not Lyme, but mold and fungus and different parasites that are very common. So stay with us. I hope you learned something. If this was too fast, go back and listen to it again. Otherwise, I'll see you next week.